Hello, welcome to Emmanuel Maths Academy. So today we'll be looking at implicit differentiation, right? So far so good. All we have done is explicit form of differentiation. Now look at what I mean. We have done something like this when you have y equal to x, or maybe y equal to x plus 1, where we have y to be in one side and the other variable to be in the other side. This is in an explicit form, right? Okay, so but when you have something like this, xy equal to 5, this is what we call implicit. This is called implicit form of a function, right? When you have x and y, when they are brought together, it is called implicit. But when you have y equal to another variable, that means y is standing on this one, just like something like you have made the subject of the formula. This is then it's called an explicit differentiation, right? Now, what do you do in implicit differentiation? When you are given something like x, y plus y equal to 5, what do? You can see that this is in explicit form. No, I mean this is in implicit form. You can actually express this in an explicit form. And what do? You can just factor out y, which will give you what? Y into bracket x plus 1 equal to 5. Then making y the subject of the formula, you now have y equal to 5 over x plus 1. Is that clear? You can see that I have just expressed this implicit differentiation into explicit. Is that clear? Then what about you if you are given something like maybe x squared plus y squared equal to 5? What do? Can you express this in explicit form? Yes, you can. You can actually have something like x squared equal to 5 minus s over 2. Then taking square root of both sides, you now have y equal to plus or minus square root of 5 minus x squared, right? Now listen. What if you go further to have something like, x power 3 plus y power 3 equal to maybe 6, right? What will you do? Will you continue expressing your function in explicit form before you can differentiate? There must be a way. There must be a way which you can use in solving something like this when you have x and y put together, right? And that method is called implicit differentiation. As simple as that. So what do we do in implicit differentiation? It's pretty simple. Look at the idea. If first you do what? If you are given something like this, as to find the dy dx, you do what? You take the derivative of both sides. You have d over dx x power 3 plus y power 3 equal to d over the dx 6, right? You take the derivative of both sides, right? Now, breaking this in further, use this to open up this bracket. You now have what? D over dx x power 3 plus d over dx y power 3 equal to this over dx. Then you have 6, right? Now look at the idea. If you differentiate this with respect to x, what do you have? You have 3x power 2. Is that correct? Because this is a function of x, remember. Then what about this? You have what? Now, listen carefully. This is y being a function of x. So how do we go about this? Remember in your chain rule, if you are given something like s power 2 plus 1 raised to power 3, you're asked to find the derivative of this. This is chain rule, right? This is chain rule. So what do? The dy, the x here is what? differentiating this is equal to the way the x will give you what? 3 times this x squared plus 1 power 2 times d over dx. Right? This is your chain rule. This is your simple chain rule. Because if you call this u, then automatically your y is equal to what? U raised to power 3. Then your dy du times du dx will give you this. Right? Now, it's the same thing with this. If you have this y raised to power 3 as a function of x, then you have what? 3y power 2, then d over dx. Differentiate y, just like your u. Differentiate the function you have inside there with respect to x, which is equal to what? D over dx 6. Is that clear? Now listen, you now have 3x power 2 plus 3y power 2. This will now become what? dy dx. Right? Equal to, if you differentiate this, it's a constant, you get 0. Let's just get rid of this, you get 0. As simple as that. You now collect like terms. You have 3y power 2 dy dx equal to minus 3x power 2. Right? If you divide both sides with the coefficient of this, now have this over 3y power 2 over 3y power 2. This will cancel this. 3 will cancel 3. You now have that your dy dx is equal to minus x squared over y squared. As simple as that. As simple as that. You can even express this as minus x over y power 2. Right? Because remember, your law of indices, it says that if you have x over y raised to power 2 is equal to x power 2 over y power 2 in your basic law of indices. So if you apply this here, you can leave your answer in this form or this form. It's still correct. Is that clear? Is that clear? So this is what we do in implicit differentiation. Let's solve for the example for you to understand better. Now let's solve this example. Look at this. Look at this. Now, solution. What do you do first? To find the derivative of this, you take the derivative of both sides, which is what? D over dx 3x power 2 minus 5y power 2 equal to d over dx 500. Right? If you differentiate this, you have 6x power 2 minus, if you differentiate this, you have 10y then dy dx equal to, this is a constant to give you 0. Right? Then this will come to this side. It will change to what? Positive, because when the sign of subtraction crosses the sign of equality, it changes to what? An addition. You now have 6x squared equal to 10y dy dx. You divide both sides by this. You have 10y. This will cancel this. That means your dy dx is equal to what? 6x power 2 over 10y. As simple as that. Now listen, let's solve this also. You're asked to differentiate this, find the derivative of this with respect to x. This is in an implicit form. We solve this using implicit differentiation. Now what do you do? Solution. Just like you did here, you take the derivative of both sides, which will give you what? D over dx x power 3 plus sine y equal to d over dx 7. Right? Now this will give you what? 3x power 2 plus cos y dy dx equal to 0. Right? This will now give you what? Cos y dy dx equal to 3x power 2. Right? Then if you divide both sides with 3 cos y, you now have cos y, cos y, cos y cancel cos y, right? You now have that dy dx is equal to this, right? You can even simplify this thing further to give you what? Equal to 3x squared sec y, because 1 over cos will give you sec, right? 1 over cos will give you sec from your trigonometric identity. As simple as that.